In this video, I want to go over how an excitation from the central nervous system turns into force production in the muscle. So I have drawn on my screen here a very simplified schematic of how this is going to work. Up here, I have a motor neuron, which eventually will be connected up to the spinal cord and the brain. And you can think of that as just an electrical conduit for electrical signals. So through a process which you can learn all about in motor control classes, electrical signals, which maybe I'll even label this as like an electrical signal, an action potential technically, gets sent down through the nervous system, down to a motor neuron, and then there's some business with neurotransmitters in here and T-tubules, et cetera, the details of which are not important for this class. But what is important is that electrical signal you can think of as being like a light switch that tells the sarcoplasmic reticulum to start dumping out calcium ions. So the sarcoplasmic reticulum, this yellow thing, is maybe effectively thought of as a big bag of calcium ions. And when it gets an electrical signal, it dumps those calcium ions out into the environment around it. And for the sarcoplasmic reticulum, it is situated right next to muscle fiber. Well, it's inside muscle fibers, right next to myofibrils, which are, of course, just sarcomeres stacked up end to end. So I have that sketched down here. Maybe this is one sarcomere. So as you saw last week, as soon as those calcium ions percolate into the individual sarcomere and the actin and myosin filaments, they enable the production of muscle force. So once calcium gets into this muscle fiber, it's going to start contracting like this. It's going to be producing muscle force. Now, one way of thinking about that production of muscle force is that it's going to be proportional to how much calcium is in the muscle. We saw last week and in the previous video here this week that there was this force length relationship for sarcomeres and of course for entire muscles. And we could think about the presence of calcium as just scaling that curve up and down. So the traditional one that we just talked about in the last video maybe looks like this. And we've got, here's the optimal muscle fiber length, and here's the maximum isometric force produced by the muscle. And we discussed last week, but I want to remind you that for situations where we do not have full activation, full muscle activation, meaning not the maximum amount of calcium ions in the environment of the sarcomere, we just maybe scale this curve down. So maybe the concentration of calcium is 50%. We could say the muscle's at 50% activation. We just multiply this whole green curve by 0.5 and it scales down, no problem. So that is, we could say that maybe that's activation level. Muscle activation is 50%. And when this electrical signal stops, the muscle will shut off. So let's just suppose let's say this sarcomere is it's going to be at some particular length. Let's say it's, I don't know, let's say it's right here. Maybe its length is, that length puts it right at this point on the force length curve. So that means that at full activation, if you're dumping the maximum amount of calcium out into the muscle, we would expect whatever this amount of force is. Maybe it's 80% of the maximum isometric force, that amount of force. And if the activation is 50%, we would expect that much force. So we can read off from the curve, given the length and what the force should be. And then in this example, I've used activation to scale that curve down. So we can think of activation as the presence of calcium ions relative to whatever amount would produce the most force. You could think of that as whatever amount of calcium fully saturates all of the individual actin-myosin filaments and gets them all producing as much force as they can, given whatever force length configuration and also force velocity configuration of the muscle. So we could just think of activation as running from 0 to 100%. And of course, 0 is the activation when you just don't have any calcium ions in the vicinity. Now, there is a subtle but important point about the relationship between excitation and activation, but I want to cover that in the next video.